Okay guys, so in this video we are going to walk through the prime factors challenge. So let's get into it. So the goal of this challenge is to compute the prime factors of a given natural number. And basically in this description here we can see that, okay, so if we have this number 60, right, then our first divisor is going to be 2, because 2 goes naturally into, like, evenly into 60, leaving us with 30. And then 2 goes into 30, leaving us with 15, but 2 does not go cleanly into 15, so we move on to the next factor, which is going to be 3, and then we can divide by that, and so on and so on until we can't do it anymore. And as you can see in this description, it's going to leave us with 2, 2, 3, and finally 5. So yeah, let's have a look. Here we have the tests that I've I made them pass basically, and here's the implementation. So I start by creating a result, just a vector of results, and if the number is less than or equal to 1, we simply return the results because there are no factors to be gathered. And then we start moving through the numbers, and then we check if the number that we are on is a prime. And the way we do that is to just go through, like we loop through all the numbers from 2 up until that number, and if anything is evenly divisible by that number, then it's not a prime and we simply return false. Otherwise we simply check that the number is not equal to 1, and then we know if it's a prime or not. And then we check whether or not it's evenly divisible into to that number, like if n is evenly divisible into the number is evenly divisible into the number that we have been provided, so that it cleanly can be devised, right? And then we simply add that number to our results, and then we do the division, and then we do a recursive call with this function again, and we store the factors that we are going to get from this recursive call, and finally we append all of those results onto our results array and break out of the loop, and then finally we return the result set. And yeah, this works fairly well. The last gigantic number we have here is causing me some issues with this implementation. I would have to kind of tweak this and figure out a faster way to do this because it's really long running, so I'm not going to show you how long it takes, but it passes finally. So yeah, this is my silly little implementation of how to solve this exercise. Have a great day.